This is Polymer, Physics 350, Homework 3, Problem 2. We have a circular arc with a radius of A and an angle alpha over the x-axis lying in the xy plane. And we want to find the E field at an arbitrary point on the z-axis. We have here is the drawing again, where the z direction or the k-hat direction is out of the page and the arc lies in the xy plane. We start with this formula here for the E field, 1 over 4 pi epsilon naught, integrating over dq over d squared, d hat. To find dq, we have the lambda dl, where dl is a d theta. D is the square root of this here, term squared, and d hat is the d vector over the magnitude of d. We take all that and we plug it in down here, and we get this here, where we need to sub in s for the Cartesian coordinates, and we have this here, comes from the back of Griffiths, and it looks like this. The charge density was constant, as was the radius, so we pulled that out of the integral, and we're integrating from negative alpha to positive alpha. Once we've set up the integral, we can then integrate, and when we go through, we do the integrate, and we end up with a y-hat component canceling out. This makes sense because we have symmetry with our arc in the y directions, but not in the x or the z directions. So we get this here. If our problem is now a full circle, we want to show that it turns out to be this here. Again, we can pull out the charge density and the radius, but in this case, both, when we integrate from 0 to 2 pi, we will get 0 in the I hat and j hat directions. This makes sense because everything in the x and y directions will be canceling out, and we'll be left with the z direction. And we end up with what we expected in the z hat direction because everything cancels out.